Okay, so in this video we're going to have an introduction to functions and more importantly look at how we can compose functions towards the end of the video. But to begin with, we're going to have a look at what exactly is a function. And it's something that you would have seen down in primary school, but the idea of what a function is sometimes lost, and to actually understand and remember what a function is tends to be helpful. So essentially what a function is it's something where you can have an input, you do certain operations on that input, and then you have an output. That's essentially the idea of a function, the simple idea of a function. Now, what I have on the screen is I have two functions. I have a function f and I have a function g. It doesn't matter if I call the function x, function y, it's just a name that we've given to the function. Now with function f, what the function does is it says input x, so input a particular value. Then what we're going to do to that value is we're going to add 10 to the value, we're then going to multiply that value by 2, and then we're going to output whatever our result is. So for example, let's try the function with x is equal to 1. So if we input 1, we then have to add 10 to that, which gives us 11. We then have to multiply it by 2, which gives us 22, and then we have to output that value, so our output is 22. So if we put 1 into our function, we get out 22. Now, how could I write that algebraically? What I could say is what the function does is it starts with a value x, we then add 10 to that value, and then we have to multiply the whole thing by 2. So I have to put it in brackets just to indicate that I'm going to multiply the whole thing by 2. And the way that we write this is we write this in the following way. We say f of x is equal to 2 multiplied by x plus 10. Now what does this notation mean? Well, it means that we have a function, which is f, and then the value of the function at the point x is equal to 2 multiplied by x plus 10. So if we wanted to work out the value of the function when f was equal to 1, we have f of 1. So our x is now 1 is equal to, well, we worked that out to be 22. Okay, if I wanted to know what f of 2 was, then I need to substitute 2 in. So I have 2 multiplied by 2 plus 10, which is going to give me 24. Now, what about the function g? Well, the function g is exactly the same as the function f, apart from the fact that our times 2 and plus 10 are the other way around. Okay, so now, for example, if we wanted to take the value 1, so input x is equal to 1, we'd have to multiply it by 2 first of all to get 2, and then we'd have to add 10 to get 12, so our output would be 12. So we can see that it's quite important to make sure we do things in the function the right way around. And how could we express the function? Well, we'd write g of x, so the value of the function g at the point x, so x is the general number we're substituting into the function, is equal to, well, we need to multiply our value of x by 2, so 2x, and then we have to add 10. Okay, so that would be the function g. But now what I'm more interested in is what happens when I try to compose the two functions together. So for example, that could mean I do the function f first. So for example, I plug in the value of 1 into f. I get my output, which was 22, and then I plug that output into g. Or it could be the other way around. That's whatever way around, we're still composing the functions. But I'm interested in how I could write that. How could I write the composition of these two functions? Well, let's have a look at our function mapping. If we follow the pathway, so if I rub all of these out, just so that we can then look at the function pathway properly. So we start with the value of x, which we put into the function f. We add 10 to that value, we get x plus 10. We multiply that value by 2, and we get 2 of x plus 10. Now what I want to do is I want to take this output and plug it into g. So I'm going to take this output and plug it into g. Now with that I'm going to multiply that by 2, which is going to give me 2 multiplied by 2 times x plus 10, which you should recognise is 4 times x plus 10. And then what I want to do is I want to add 10 to that. So I have 4 multiplied by x plus 10 plus 10. and that's the output I get if I start with a value in f and then output that value and plug it into G. Now how could I write that algebraically? What would my notation have to be? Well, we have the function G, and what exactly are we putting into that function? What is our value of x? Well, the value of x is going to be f of x. So I'm taking a value of x, I'm working out what its value at f is, and then I'm working out what the value at g is. In other words, when we have function notation, we always go from the inside to the outside, so that's the way you should read it. And I could work this out because, well, what's f of x? Well, we know f of x is 2x plus 10. So if I now put this into g of x, what do I get? What this means is it means whenever I see an x, I plug this in. So I have 2 multiplied by 2 times x plus 10. Okay, so this x has now become 2 times x plus 10, and then I have to add my 10. Okay, and I expand the bracket and I get 4 multiplied by x plus 10, which, if you notice, is exactly the same thing we got when we went through our function machine. But what I want you to try and do is I want you to pause the video and tell me what would happen if I start with the value of x in G, worked out the output, and then plugged the output from G into f. In other words, I want you to tell me what f of g of x would be. Okay, so do it both ways. First, go through the function machine and follow the arrows, and then try to work it out algebraically. Okay, have a go, pause the video, and come back when you're ready. Okay, so let's have a go. So now what we're doing is we're starting with a value in G, so we're inputting an x. So what we're going to do is we're going to multiply that value of x by 2 to get 2x, and then we're going to add 10, so we get 2x plus 10. 2x plus 10 is our output, it's our g of x. And now what we want to do is we want to feed this value into f. So we're going to take our 2x plus 10 and add another 10. So we have our 2x plus 10 and we add a 10. That's going to give us 2x plus 20. Now we follow the arrow and we have to multiply this by 2. So we have 2 times 2x plus 20, which gives us 4x plus 40. And that's our output. That's what we'd get if we were to do G first and then f. And let's try showing that using what we know about the functions. We want to write down what the value of the function f would be at the point g of x. So we have f of, well, we know g of x is 2x plus 10. And if we substitute 2x plus 10 into our f of x, we have 2 multiplied by, and whenever we see an x, we have to replace it with 2x plus 10. And we have to add another 10 to that. And as you can see, we get 4x plus 40 if we collect the terms and then expand the brackets. Okay, so what have we learnt here? Well, what we've learned is we've learnt how to express function notation. If I move on to the next slide, we've learned that f of x means what is the value of the function f at the point x. We've learnt that if we had, for example, h of x, that means tell me what the value of the function h is at the point x. And if we had hf of x, then what would that mean? Well, that would mean, if we put these in brackets, that would mean tell me what the value of the function h is at the point f of x. Or in other words, if we remember our function machine, that would mean plug in the value of x into f, take that output, and then plug that output into h, and see what you get overall. Okay, so what I have is I have an exercise for you to do. I'm going to bring it up onto the screen, pause the video, have a go at the exercise, come back, and then we'll go through the solution. Okay, so pause the video, have a go at the questions, and come back once you've had a go, and we'll go through the work solution. Okay, so welcome back if you did have a go, and let's have a look at what this question wants us to do. We're told that two functions f and g are defined such that f of x is equal to x squared minus 1 and g of x is equal to 4x. And what we have to do in part A is find f of g of x. Now remember what this means, okay? So f of g of x, we work from the inside. So we want to work out the value of the function f at the point g of x. Okay, so remember our function machine. First of all, what's g of x? Well, we're told that g of x is equal to 4. And now we want to work out what f is. Essentially, we want to replace all of our x's with a 4x, because our input's not x anymore, our input's 4x. So we just replace all of our x's with 4x. So instead of having x squared, we're going to have 4x squared, and then we take away 1. 4x squared, well, that's going to be 16x squared, and then we take away 1. And if you want, you could factorise it to 4x minus 1, 4x plus 1. Okay, that's just a difference of two squares. Now what about g f of x? You might think it's going to be the exact same thing as in A, but that's the key thing that we just learned, okay? When you compose functions, the order does matter. You can't just do it any way round. They're not necessarily the same. So g f of x, what does this mean? Well, we want to know the value of the function g at f of x. Okay, now we know that f of x is x squared minus 1, so we have g of x squared minus 1, and we know that g of x is 4x, but we can see that our x is now x squared minus 1. So we just replace our x over here by x squared minus 1, and we have 4 times x squared minus 1. And you could write this as 4x minus 1, x plus 1, again using the difference of two squares if you wanted to. Now for the final part of the question, we're asked to work out g f of 1 minus f of g of 1. Okay, now this should be fairly straightforward. So what's g f of 1? Well, we worked out g of f of x to be 4 times x squared minus 1. Now if we want to work out g f of 1, then we see all we've done is replace our x by 1. So we do the exact same thing here. We replace our x by 1, so we get 1 squared minus 1, which is 4 times 0, which is 0. So we have that g f of 1 is 0. fg of 1, well, what's that going to be? Well, we worked out that fg of x is equal to 4x minus 1 multiplied by 4x plus 1. If we want to then work out fg of 1, then again we just replace our x's. So we have 4 times by 1 minus 1 multiplied by 4 times by 1 plus 1. And that's just going to give us 3 multiplied by 5, which is 15. So to answer the question, gf of 1 minus fg of 1 is going to be 0, because that's gf of 1 minus fg of 1, which is 15, which is minus 15. Okay, and that's how we answer this question. This is very similar to the sort of thing that you're probably going to get. You're going to be asked to compose functions, to evaluate functions at particular points, and it's important that you understand the order. The order is very important to understand, and I think just having the function machine in your head is the best way to understand how the order goes and to avoid confusion. Okay? So that brings us to the end of this particular video. Hopefully you found it useful. In the next video we'll be looking at inverse functions, and then in the video after that we'll be looking at some more examples on functions. Okay, but for now that brings us to the end of this particular video. If you found the video useful, don't forget to give the video a thumbs up, don't forget to subscribe, and I'll see you in the next video.